Wydział Inżynierii Mechanicznej.
Hello and welcome. I'm so glad to have you with us. So my first question would be, what is the use of 3D printing in medicine? In other words, what can be printed?
Well, 3D printing is a technology which is particularly well suited for medical applications because it's relatively easy to manufacture intricate organic anatomical shapes using even the cheapest 3D printers. Moreover, you are not confined with the limits of traditional mass production or serial production because your 3D printer can produce one object and then you can immediately shift to another object without preparing any molds or tooling or making any additional costs. So you have a big potential in, let's say, personalized medicine, personalized medical devices. You can produce objects tailored for specific patients like implants, orthoses, prostheses, and many others. In general, there are three main groups of applications of 3D printing in medicine. First, it can be used by biomedical engineer. This particular engineer can design something new like a wheelchair or a surgical tool, and they can quickly prototype what they are designing using the 3D printing. And so they can quickly check if their design assumptions are correct. Second, a doctor can use it, more specifically a surgeon. So 3D printed supplies can be taken into an operating room and used before or during a surgery. I have some examples here. So, for example, this is a template of lower jaw used for the jaw reconstruction surgery. This is a result of our cooperation with Poznań University of Medical Sciences, and this was designed digitally with using medical imaging and sterilized and taken into an operating room and used during the reconstruction procedure to reconstruct the missing part of the lower jaw using patient's own bones. And thanks to use of this template, the operation was shortened by 2 hours, and the results of healing were generally better. So this is what can be used. I've got some other examples here, like for example, an artificial kidney, which also can be used for a simulated operation. So after operation, it looks like this. It's then sewed, as you can see. So there are many examples of things that you can take into the operating room or use before. And the third category of medical applications of 3D printing is the one which is most interesting for myself, is 3D printing directly for use by patients. So whatever comes of your 3D printer can be used directly by a patient. This includes orthoses, prosthetics, implants, and other personalized medical devices, which can be custom made for a specific patient. And here I've got some examples made by my team. So, for example, this is a cosmetic hand prosthesis made for a 1.5-year-old boy. And here is a mechanical prosthesis for riding a bicycle for a 3-year-old girl, as you can tell. Basically, you can do very personalized things. Also for adult patients. Here is an open work orthosis for wrist fracture. And you couldn't obtain such a shape with all these open works on regular manufacturing. It is only achievable by 3D printing. Of course, much more can be done on more sophisticated designs as well.
Now it looks extremely interesting, but what makes 3D printed prosthetics better than the ordinary ones?
Well, from my point of view, the biggest difference that we are trying to make is availability, because children with amputations or birth defects rarely use prostheses because they usually can't afford it. A traditionally made high-quality upper limb prosthesis is a cost like 3 or 4 medium salaries in Poland, like 10,000 zlotys, and you need to switch it for a new one each half a year or 1 year, like a pair of shoes. Children grow very quickly, so most of the parents can't afford it. So our approach allows us to deliver prostheses very quickly, in a few days, and by a fraction of price. So the estimated cost of our supplies is no more than 100 euros or 500 zlotys. Of course, we also try to improve the designs and propose entirely new ones, and 3D printing is something that allows us to make it very quickly. So there's a need for a particular type of prosthesis, and we can design it, test it, make another iteration, and it's all very quickly. So this is what helps. And traditionally, the prosthetics are shaped manually. So that's another thing, because they are shaped manually. There is no digital representation, and the whole process is in the hands of a skilled technician. There is, of course, a digital process, which is better, in which you 3D scan a patient limb, for example, and then you can manufacture, you can design the prosthesis inside a computer-aided design program. And this requires much of work by a skilled engineer. And this is what we also do. But what I'm doing, what I'm trying to achieve is automation. I'm automating these processes. So we use some simple AI, knowledge engineering, and we basically want our prostheses to design themselves. So they will be automatically designed on the basis of patient measurement data supported by 3D scanning.
Absolutely. It sounds very promising. Thank you so much for being with us.
Thank you.
Politechnika Poznańska. Warto tu studiować.